So page 323, question number 8. So we want to draw an energy versus time graph for mass A and mass B as they move. Now, we have no outside forces acting on the system, so we know our mechanical energy is going to stay the same. So I can draw that in right off the start. My mechanical energy of the system does not change. We're dealing with an ideal system, not worrying about friction, etc. Now, let's take a look at mass A and what's going to happen. Its gravitational potential energy is going to go down. Its height's changing. It's going to change into kinetic energy as it goes down until it crashes into the ground. So that gravitational potential energy is going to start at the top because that's all the mechanical energy is, and it's going to go down and down and down and down until it reaches 0. So that is going to be my kinetic energy for mass A. Now, the interesting thing is what's happening on the other side. Mass B is going to move up, so it's going to gain gravitational potential energy, but not all the mechanical energy at the start is going to change into gravitational potential energy here. So when I did the calculations, I ended up with a gravitational potential energy of B of 20 joules. So when we take a look at that, I'm going to mark that point right there, 20 joules. So that is sum of my mechanical energy of the system is going to change into gravitational potential energy. So it is my gravitational potential energy of object B. Both of them, however, are also going to have some kinetic energy. So my gravitational potential energy is part of my mechanical energy at the end. The rest of my mechanical energy is going to have to be made up by the kinetic energy of these two objects. And I did a calculation. I got 12.9 joules of energy. So I'm going to mark that down as this point at the end. Now remember, we've got a height of 6 squares, 1, 2, 3, 4, 5, 6. So my energy at the end, the kinetic energy plus the gravitational energy, so I've got 2 squares tall plus 4 squares gives me 6 squares tall. So this line here is going to represent my kinetic energy of object A and object B. So the key thing here is when we are taking a look at these, this one is 2 squares. This one is 4 squares, and it has to add up to give me my mechanical energy at the end, which is 6 squares tall. And that's how we determine our graph for that energy. Again, graph paper makes it a lot easier in order to understand what's going on and represent all of the mechanical energy before releasing the masses and after we release the masses.